Hello, I'm Lena Taro. In this video, I'll be showing you how to use the TI-89 to transform data to achieve linearity. We'll be using an example that's found in Chapter 12, Section 2 of the Practice of Statistics. In this example, we have distance from the Sun and period of revolution. The distance from the Sun is in astronomical units. The period of revolution is in Earth years. You can see I've already entered the data in List 1 and List 2. Let's begin by plotting the data. Hit F2, choose Plot Setup, choose F1 to define the plot. We'll choose Type Scatter Plot. Notice there are other types of plots, but we're going to do a scatter plot. And our X's are stored in List 1, so I need to type in List 1 here. I'll use the down arrow to get to the next field. My Y's are stored in List 2, and I like to hit the alpha lock key to make it a little easier to type in all those letters. We're going to hit Enter, and then we say F5, Zoom Data. We can see that there's a slight curve to the scatter plot. This means that a linear model is not a good fit. To see if a power model is a good fit or an exponential model is a good fit, we need to define lists 3 and 4 as a natural log of lists 1 and 2. To do this, we'll hit Second, Quit, to escape, and go back to the Stat List Editor. And we'll go to the top of list 3 and we'll define list 3 to be the natural log of list 1. To do this, hit Second, then the X key. That's how we get natural log. Then to get list 1, hit Second, then the minus sign to get a list of variables, and choose list 1. Don't forget the right parenthesis. Hit Enter. This is the natural log of the values in list 1. We'll do the same thing for list 4. In list 4, we want that to be the natural log of the values in list 2. Make sure you choose list 2 and not list 1. Now let's create 2 new scatter plots to see whether an exponential model would be better or a power model. So hit F2 for plots, Option 1 for plot setup, F1 to define the plot, and what we need to do here is change our Y's to be list 4. So go to the very end of the list here, or where it says list 2, back up and delete the number 2, change it to a 4, hit Enter twice, and F5 to zoom data. Clearly, an exponential model is not appropriate. Let's see if a power model might be better. So Second, Quit to get out of there, and we have to go back to our Stat List Editor, and F2 for plots, plot setup, F1 define, and we're going to change this to be list 3 for our X's. That was the natural log of list 1. Hit Enter and Enter, and then F5 to zoom data. This looks much better. I would say a power model is more appropriate. Now let's perform a linear regression on our transform data. To do this, let's quit out of here or escape out of here. Go back to our Stat List Editor app. Choose F4, Calculate, Option 3, Regressions, and Option 1, Linear Regression. Our X's will be list 3, so we need to fix this. And our Y list will be our transformed list of the Y, so that's list 4. And we'll store our equation in Y1, frequency is 1, and we'll just come down here and say OK. And we can see our slope is 1.49 and our y-intercept is about 0. And notice we have a very high r and r squared value. This is a very, very good fit. In fact, an r value of 1 would indicate that it's a perfect fit. Next, let's take a look at a scatter plot of the residuals. Once again, F2 for plots, plot setup, F1 define. Down here for Y, we're going to have our list of residuals. Hit second, minus for varlink, and notice if you scroll down, there's a list of residuals that's been calculated. Hit enter, and F5 zoom data, and there's our residual plot. Finally, we'd like to use our regression equation to make a prediction for the period of revolution of Eris, which is 102.15 astronomical units from the Sun. To do this, we need to first exit out of here and go to the home screen so we can do some calculations. We first want to take the natural log of our value of 102.15. That's our explanatory variable, the astronomical units. Then we need to substitute that into our regression equation. So I'm going to go to second, varlink, choose our regression equation, which if you remember we stored in Y1, and say that I want to take and substitute 4.62644 into our regression equation. And then I need to take e to this power to undo the natural logarithm. To do that, hit second, or actually we need to hit diamond and then the X button, and we want to take e to the 6.93927 power. So the period of revolution of Eris would be about 1,032 years, Earth years.